Right, so interior would be in between the parallel lines that I drew this other line through. Same side would be the angles on each one that happen to lie on the same side. So an example would be angle 4 and 5. Because they are on the same side of the line that goes through the two parallel lines. What is the other example? 3 and 6. All right, same side interior angles. Are there any other examples? All right, no, there's no other examples. Just those two in this example. All right, I'll skip supplemental angles for right now. Let's look at alternate exterior angles. All right, so we're not looking at the interior anymore. We're going to look at the exterior now. So these regions, the outside of the parallel lines, and kind of use the names as your guide. You can probably figure it out. If it's alternate exterior angles, then one example would be angle 1 and angle 7. All right, angle 1 and angle 7, because they're both on the exterior, but they're alternate. They're not same side anymore. The other example would be angle 2 and angle 8. All right, so that's alternate exterior angles. Now think about what alternate interior angles will probably be. All right, so now we're going to look at the interior, so in between the parallel lines. And they're going to be on alternate sides, so opposite of same side. So an example would be angle 4 and angle 6. What would be the other example? All right, 3 and 5. So supplemental angles I skipped because there are so many examples of supplemental angles in this picture. I don't think I can fit them all. But supplemental angles add up to 180 degrees. So they add to 180 degrees. They basically make a straight line. So some examples of supplemental angles could be like 1 and 2. All right, so angle 1 and angle 2 are supplemental because when you add them together, they equal 180. All right, they make a straight line. What would be another example on this page? 4 and 3, good. So angle 4 and angle 3. Could I also go like this way, like angle, sorry, that didn't mean to make that look diagonal. Could I also go this way, like angle 1 and angle 4? Right? Yes, I can, because they also make a straight line. So that's why there's so many examples on here. So I would write it as these few that we mentioned, and then I would just write and more. All right, but any two angles that are next to each other that equal 180 degrees once you add them are going to be your supplemental angles. All the other ones, those are the only examples of those for each one that we did for this paper. Questions about that? All right, so as you can see, so that bottom portion underneath that slide says the line that intersects the parallel lines is called a transversal. So I would highlight that part. So if you see a problem that says transversal line AB or whatever it says, all right, the line that intersects the parallel lines, also known as the transversal, creates multiple pairs of angles with similar relationships. So the transversal line is the one that intersects the two parallel lines. All right. On the next page, we're going to look more closely at vertical angles because they do have a special relationship. Like we said before, they're angles that are across from each other when two lines intersect. And again, they do have a special relationship. That relationship is known as the vertical angles theorem, which says that vertical angles are congruent to each other. So when two lines intersect, the angles that are across will have the same measure, just like this picture. All right, they intersect, these two lines. In the red, those are vertical to each other. And then in the blue, those are vertical to each other, and they have the same measurements. Okay. Alternate interior angles theorem. So like we said, the interior is referring to in between the parallel lines. So if you want to make markings on these pages on the picture, I would do that. So this would be your interior. And this theorem says that if a transversal intersects two parallel lines, alternate interior angles are congruent. Just like if you're in GO2 this morning, we kind of talked about this when we did the trig functions. All right, we know what those measurements are if they're missing because the alternate interior angles will be the same. All right, next one. Corresponding angles postulate. So just like corresponding triangles, we have two sets of angles and they're corresponding if they're in the same position. So like 1 corresponds to 5, 2 corresponds to 6, and so on. So if a transversal intersects two parallel lines, the corresponding angles will be congruent. And that's like what we said in the beginning. Angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. All right. Next, we have alternate exterior angles theorem. So alternate exterior angles theorem says that if we have a transversal intersecting the two parallel lines, the alternate exterior angles are congruent. So the reason why we're kind of going through these is because if we need to make a proof, we can do that by using these theorems as our reasons, as our justification. All right, we can say that angle 2 is congruent to angle 8 because of the alternate exterior angles theorem. All right, questions? All right, same side interior angles theorem. So you're kind of seeing the pattern here. It says that if transversal line intersects two parallel lines, the same side interior angles are supplementary. So what does supplementary mean again? They add to 180. So the same side interior angles are not congruent. They're supplementary, which means that they add to 180. All right. So next one. Okay, so we're going to talk about, we're going to do a proof together, if you will. And just kind of think of it as if you have a word problem. And it's telling you to see that CD is perpendicular bisector of AB. So you would have to know what perpendicular does. So what does perpendicular mean when two lines are perpendicular to each other? Kind of, yeah, they have opposite slopes. So what do perpendicular lines always create? Right, they create 90-degree angles, don't they? They create 90-degree angles all around. And we know that because it says perpendicular. It also says that line CD is a bisector of AB. What does bisector mean? It means cutting in half, right? So we're putting a line where it separates something into two equal parts. So bisector, by definition, means that we're going to have two equal parts. All right, with that little piece of information, we can prove that point C is equidistant or the same distance away from points A and C. All right, so we're proving that basically side AC is congruent to side CBC. All right, so we're going to make our proof here in just a second, but since we know that they're perpendicular, I know there's going to be a right angle here and a right angle here. And since this line bisects the other line, I know that these lines are going to be the same distance. All right, so just keep that into consideration. That's what the instructions tell us. Questions so far? So we will create a 2-column proof. So that means we're going to have statements on one side and reasons or justifications on the other side. First, we usually start with what we are given. So we can say line CD is a perpendicular bisector of line AB. All right, and the reason for that, the first reason you should have is usually given to you in the direction. All right, so my reason would be given. They gave me that information. That's what we know. All right, these other things that I labeled, so we could say line AE is congruent to line BE, right? We said that a little bit ago. What would be our reasoning for that? How do we know that they are the same distance? Because of bisector, right? So you can put for the reason, definition, of bisector, or you can even be more specific. You could say definition of bisector is creating two equal halves. All right, so definition of bisector is creating two equal halves. That's how we know that this line is the same or congruent to this line. All right, we can also say angle AEC, and there's a reason why I have to put the whole thing there. I can't just put angle E. We can say angle AEC is congruent to angle BEC. All right, we kind of wrote that in on the picture. We know that they're 90-degree angles. What told us that? So what's our reason for stating that? Good. We know that perpendicular lines create 90-degree angles. So for my reason, I would put definition of perpendicular lines. All right, we've learned before, so it's like a theorem, I guess you could say, or a postulate that perpendicular lines create 90-degree angles. All right. Think of the postulates that we did yesterday, like side, 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 angle, side, things like that. Which postulate do you think we can use to say that these two triangles are congruent? We know that this side, these sides are congruent to each other. You know that they have an angle in common, so far we have S and an A. Aside from the green one that we're trying to prove, is there another thing that they have in common for sure? What about this side, right? Does this side match this side? It should, because the same line is drawn through it, right? So we have one side that's congruent, we have an angle that's congruent, and we have a side on the other side of that that's also congruent. Make sense? So I can say triangle AEC is congruent to triangle BEC by side, angle, side, right? Because they have this side in common, which we proved earlier, an angle in common, which we proved earlier, and another side in common, which we can see from the diagram that was given to us. All right. And since we know that these triangles are congruent to each other, we're really close to proving that side AC is congruent to side BC. All right, anyone happen to know the reason why we can say that those two sides are the same? All right, since we already established that the two triangles are congruent in the previous step, we can say that the corresponding sides are congruent. And the reasoning for it is corresponding parts of a triangle are congruent. So if we've established that the triangles are congruent, well, we can say that this side is congruent to that side. So just wrap it up now. It wanted to prove that they were the same distance away. So we can say point C is equidistant, or the same distance away, from points A and B. All right, point C is equidistant from points A and B. I guess we could put equidistance means equal, or definition of congruent. All right, and then we've proven it, right? We've explained every single reason and established every single part as being congruent to safely say that those points are the equidistant away from each other. All right, does that make sense? Questions? All right, so we're gonna pause there. I'll let you have a 15-minute break. So this is your assignment for 3.01. So instead of having a separate worksheet or a Google form, answer all of these questions. If you're stuck on any of them, let me know. Notice that this picture to the left does not exactly match the example that we did. It is numbered a little bit differently. So you do actually have to check, are these alternate interior angles? Are these vertical angles? And then name all the pairs. All right, to answer those 5 questions, once you've answered all those, put the guided notes in the basket. I should be able to pass it back to you before you leave today. So I'll just give you about 15 minutes to answer those questions. So the last page of your 3.01.